Now we'll be talking about rate of change. Rate of change, as you can see, it's the change over a certain amount of time. That's why we write it as dy dt. D is the difference in y, and dt is the difference in time. So something changes over a change in time, that's your rate of change. Okay, a classic example is this balloon, right? First you have a small balloon with a certain radius and a certain surface area and a certain volume, right? They're all related by spherical formula. So imagine it's a sphere, right? And then we blow air into it. So the radius increases, but at the same time, the volume increases and the surface area increases, right? So because of that, we can relate all of these to each other. And let's say it increases in a certain amount of time, maybe 2 seconds or 1 second, right? So let's look at this question. We have a balloon, and it's given that for every second I blow into this balloon, it increases the radius by 1 centimeter. So the dr dt is actually 1 centimeter per second, right? So that's the rate of change of radius. So this is usually given, right? So now, what if I wanted to find the rate of change of the surface area or the rate of change of the volume? So in this part, I'll consider all possibilities and I'll show you what to do when there's certain unknowns. Okay, so this is given. Now let's see what happens if I want to try to find the rate of change of the area. So you know that the surface area is actually related to the radius by this formula, right? So step 1 is always understanding what formula to use given a situation. So usually if it's a sphere, then it's the formula for the surface area of a sphere. If it was a cube, then it's the surface area of a cube, vice versa, right? So you have this. And you know that dA dr, so as r changes, a will change, right? So if I differentiate this equation, I'll get this, right? So this says that for every increase in 1 cm in radius, I increase it by 8 pi cm in surface area, right? So this is dA dr. The thing is, how do I find dA dt? So this will relate to your chain rule. Okay, I'll show you this later on. But let's consider another possibility where they ask for the change in volume, right? And this is the volume equation. And if I differentiate it, I get the rate of change of volume as the radius changes, right? So as radius increases, the volume would increase by this much, right? So always look at the question, what kind of thing are they looking for? They might give you radius, but are they looking for the surface area or are they looking for the volume, right? So always make sure you do the right formula. This is one thing. Another thing is to solve this, right? Because you need this to be a certain value to sub it into the chain rule. How do you get a value from this? Well, there needs to be a certain information given. So here are some examples of info that they can give in the question. They can say that what's the rate of change of volume when r equals 2. So when the radius is 2 cm, what's the rate of change of volume? Because at different radius, maybe when the radius is 3, maybe when the radius is 4, there's actually a different rate of change of the volume or surface area, right? So they have to specify when it is. If they don't give this, they might give it in a less straightforward way where you have to solve it yourself. Maybe they'll say when the surface area is 16 pi, then you have to solve, right? Sub this in to this equation and solve to find r. Then you continue that regularly, sub that into here, right? So that's if they give this. They can also give the other one when volume is this much, right? And once again, just sub it into this, right? So always list out what you're given and what you need to find, all right? And always try to relate them to each other. So that's the step. Now all about the chain rule. So the chain rule is kind of intuitive, as you can see. If I wanted to find the rate of change of surface area, dA dt, it's actually equals to the dr dt times dA dr. What does this mean? Rate of change of surface area is the same as the rate of change of the radius, which was given before, as dA dr. So as the radius increases, the area increases, right? So if you notice something, I can actually just, since this is a fraction, right, and they times each other, and these are the same, I can just cut them out. Therefore, this equals to dA dt, right? Got that? So that's why the chain rule is like this. So what you have to do is to write down the chain rule based on what you have and what you need. For example, if the question was asking for dA dt, I would list out dA dt equals to, and they gave dr dt times dA dr. So now, after I finish this, I just have to sub in the values of what I had and I had found out into this equation to find this value, right? So we'll see an example later on. Another question they might ask, what's the rate of change of the volume? Same thing as before, but instead of saying dA, I use dr and dV. So once again, I can cut these out. Alright, so that's how the chain rule works. So always remember, put the thing you're looking for in the right place, right? Because you can't just cancel willy-nilly. They have to be one on top, one on the bottom, on the same side of the equation, right? So always make sure it's mathematically logical. Now, the question is, what is dA dt based on the situation, right? So let's say when r equals 2, I would sub in for dA dt, I would sub in r equals 2, so 8 pi 2, which is 16 pi. Right, so this is my dA dr. So I know that dA dr is 16 pi. And I know that dr dt was given 1. Therefore, my answer is 16 pi. Always remember your unit. So the unit is based on what's going on here. So this is dA dt, A surface area. And you know that surface area should be in this case it was cm, so it was cm squared. And since it's a rate, it's per unit time. So here is every second, so I put per second, right? And the same goes for dV dt. If I ask for this, sub in the values into this equation, and you would find the answer for dV dt. Alright, so sometimes they could play around with this. Okay, they give certain information. Some information wouldn't actually be useful, but some information might be used to find out another piece of information. So always list out what you have, what you need, and then what you want, and always remember the unit at the end.